Today, I will discuss with a very special type of concept which is pseudo force. I am Datta sir. I am a senior ex-professor of a number one IIT JEE Institute of India, and I am teaching IIT JEE students for a long time. So I am making videos for various concepts of physics in which students are struggling. So this concept, pseudo force, is a very peculiar concept. Here I have seen many of the students are facing difficulty. So I am making this video. If you are one of them, please listen to this video very carefully. So let me go to the topic. So today's topic is pseudo force. So let me start with an example. Suppose there is a bus. You see the green diagram. There is a bus in which a man B is standing and another man A is standing on the road. Now, inside the bus, there is a box of mass M and the floor of the bus is rough and the bus is moving with an acceleration A. Now, let us say, for just imagine that the bus is wall is made of glass so that it is visible from outside, and two persons A and B both are observing the particular box of mass M. Now, their observation is going to be different because A will see that the mass M is moving with the bus, that means with an acceleration A. But since observer B is moving with the bus, to him it will appear that the box is at rest. Now, if they individually want to apply Newton's law formula, because Newton's law says F equal to ma, where F is the force applied and A is the acceleration of the body of mass M. So, the man A who is on the ground and at rest, he will see that the mass has a acceleration of A. And there is only one force that can pull the mass, that is the friction force, friction of the floor of the bus. Let us say that is F. So he will very comfortably write F equal to ma, because the mass is moving with an acceleration and there is only one force, that is F. Now, F is a real force, friction, so it is irrespective of the frame. In all frame, the real force remains same. Now, B has a problem. B sees that the mass M is at rest, but there is a force F acting on the mass. So, if the force is acting on the mass and the mass is at rest, then it is a problem for B. If he wants to apply Newton's law to this mass, then his thinking will be that the mass has no acceleration, mass is at rest, so the net force should be zero. So, if he has to write the equation, he has to make a correction. He has to write F minus ma equal to 0. Now, question is, what is minus ma? Minus ma is the correction he has made so that the equation matches. But in this equation, anything in the right, anything in the left denotes force. Anything in the right is mass into acceleration. Now, in the lower equation for the B, in the left there are two terms. One is F, one is minus ma. Now, both of them has the dimension of a force, but minus ma is not actually a force, but here it is acting as a force. Then his equation will tell you. So, minus ma is, although not a force, it is behaving like a force to observer B who is in the frame that is in the bus which is accelerating. Means he is in an accelerating frame. So any observer who is in accelerating frame, he has to make a correction to the force equation when applying the Newton's law. Now this accelerating frame is called a non-inertial frame, and non-accelerating frame is called an inertial frame. So we can frame a general rule that when applied in a non-inertial frame, there has to be a correction to force equation. And what is that correction? That is minus ma. Minus ma. But in the above equation, number 1, ma is in right side. So it is not a force. It is mass into acceleration. But when it is in left side, in second equation, it is behaving like a force. It has to be a force. So this force, although not actual force, it behaves like a force and it is named as a pseudo force. So it may appear to be a bit surprising to you, but this is a real situation. Any observer who is in an inertial frame, for him the force behaves like a real force, but it is not a real force, but it is his apprehension that it behaves like a force. That means any force which is real, that is same to all the observer, but a observer who is in a non-inertial frame, he has to make a correction which is called pseudo force. Let us take another example. Suppose in the same example, the bus floor is smooth. So if the floor is smooth, there is no friction. In that case, bus is accelerating, but the mass will not move from its place. Mass will be at rest with respect to ground. But bus is proceeding ahead. So the observer B will see that mass is proceeding towards him with an acceleration A. For A here, there is no problem because A sees that M is at rest, so force is also 0, so no problem for A. But for B, he sees that mass is moving towards him with an acceleration A. This cannot happen without any force. So there must be a force which is also minus ma. This is actually not a force, but he thinks there is a force acting like this. To him, it appears to be a real force, but it is not a force. It is actually a correction. So this minus ma has become a pseudo force here. That means in any case where the observer is in an accelerating frame or non-inertial frame, we have to add a pseudo force. So pseudo force is, see the underlined, pseudo force is the what? Pseudo force is negative of mass of the system into acceleration of the frame. Here mass of the system means mass of the box is m, acceleration of the frame means acceleration of the bus is a. So m into a, and then we give a negative. So it is minus m into a. Now students make mistake very often. In type of acceleration of frame, they sometimes give acceleration of the object. But this has to be very carefully noted. It is mass of the system into acceleration of the frame. It is not mass of the frame. It is not acceleration of the system. It is mass of the system into acceleration of the frame. That means where acceleration of the frame is 0, pseudo force is 0. If there is acceleration frame, this is mass of system into acceleration of frame with a negative sign. That means wherever a free body diagram is to be drawn in a non-inertial frame, pseudo force has to be considered, must. And of course, the real forces are also to be considered, because real forces are always same in all frame. Let us take a lift problem. Suppose a lift is going up with an acceleration A, and a mass is hanging from its roof. So we have to find the tension. So there are two forces here. One is tension, one is mg. Now, to an observer at A on the ground, he sees that mass m is going up with an acceleration with the lift. So tension must be greater than mg here. So T minus mg has to be equal to ma, because mass is moving up with an acceleration. So he writes T minus m equal to ma and T equal to m into g plus a. That means g is replaced by g plus a here. For B, B is moving himself with that lift. So to him the mass m is at rest. So he will write T minus mg, but he will write also a pseudo force minus ma. So he will write T minus mg equal to minus ma equal to 0. That means for him also result is T equal to m into g plus a. Now question is, you may ask the question that both are getting same result and the equations are also algebraically the same. Only ma is in right side on upper equation, ma is in left side in lower equation. See, algebraically equation 1 and 2 are same. This is correct. But in physics they are different, because in physics equation anything in left side is a force, anything in right side is mass into acceleration. So right side m is mass, g plus a is acceleration, but left side in the second equation T is also force, minus mg is force, minus ma is also force, and that minus ma is nothing but pseudo force. So pseudo force is minus m into a. So that means the confusion has to be corrected. Here lies the confusion. Many students are confused about this pseudo force, but the general rule is, whenever there is an observer, mind it, observer should be in a non-inertial frame. Then only pseudo force has to be added. Or I can say, if the free body diagram is drawn in a non-inertial frame, then pseudo force has to be added. But if the free body diagram is drawn in ground frame, no pseudo force is to be added. I hope the concept has been clear to you, but you should listen to this repeatedly and follow the notes given, because this clarification has to be made it is very necessary for solving any problem in mechanics, because very often you will find problems with non-inertial frame. So if you are benefited by this video, please like this video, share this video as much as you can, and also subscribe to this channel, because in this channel I will bring all the concepts of physics for your benefit regularly. Also, please comment on this and let me know if you want to know a particular concept from me. So, thank you very much for listening.